In this video, we're finally connecting atomic structure to the periodic table. Everything should start to make sense. If you understood protons, electrons and shells, everything will start to work in your favour.
Chemists needed a way to organize elements, not alphabetically, not by color, but by behavior. The periodic table lets us see patterns in how elements react, and those patterns all come back to electrons. As you move across the table, atomic number increases by 1 each time. Atomic number means the number of protons, so every step to the right, we're adding 1 proton, and once protons increase, electron structure changes too. Rows are called periods, and here's the key rule. The period number tells you how many electron shells the atoms have. For example, an element in period 3 would have 3 shells. So rows tell us something about shells. Columns tell us something even more important. Columns in the periodic table are called groups. In the modern periodic table, there are actually 18 groups, but for GCSE exam, you only need to focus on the 4 highlighted groups. For those main groups, the group number tells you how many electrons are in the outer shell. Group 1 elements have 1 outer electron, Group 2 have 2, Group 7 have 7, and Group 0 already have full outer shells. This outer shell is what controls reactivity. That's why elements in the same group behave in similar ways. For example, sodium and potassium are both in Group 1. They both have 1 outer electron, so they both react in very similar ways. So for GCSE, don't panic about the 18 groups, focus on the ones your exam board actually examines. All Group 1 elements have 1 outer electron. Atoms want a full outer shell, so they lose that 1 electron easily, leaving a +1 charge. But here's the exam favourite. As you go down Group 1, reactivity increases. This is because the outer electron is further from the nucleus. The attraction is weaker, so it's easier to lose. Group 7 behaves slightly differently. Group 7 elements have 7 outer electrons. They need 1 more to fill the shell, so they gain 1 electron and become negative, and their reactivity trend goes the opposite way. As you go down Group 7, reactivity decreases because the outer shell is further away. The nucleus attracts incoming electrons less strongly. One group doesn't react at all. Noble gases already have full outer shells. They don't want to gain or lose electrons, so they don't react. And in the center of the table, we have something totally different. These are the transition metals. They're less reactive than alkali metals, they have higher melting points, and many form colored compounds. Now let's test whether you actually understood any of this. Let's apply this properly. Element X is in Group 2 and period 3. They'll ask you something like this. How many outer electrons? How many shells? Now remember the rule. Group tells you outer electrons. Period tells you shells. So if it's in Group 2, it has 2 outer electrons. And if it's in period 3, it has 3 shells. Group number equals outer electrons. Period number equals number of shells. That is exactly how they test it. If that felt easy, well done. It means you totally understood what I'm talking about. If you get 3 things from this video, it's this. Atomic number tells you the number of protons, periods tell you the number of shells, and groups tell you the number of outer electrons. And those outer electrons, they control reactivity. That's why Group 1 gets more reactive down the group, and that's why Group 7 gets less reactive down the group. It's not random, it's structure controlling their behavior. And that's exactly how examiners want you thinking. To reiterate, this is paper 1 content. If this feels solid, good. If not, rewatch it now before moving on. Next up, we go deeper into trends and why they happen. Mr. knows, knowledge beats luck.